In this lesson, we'll go through several examples on how to find the eigenvalues of a matrix. The question reads, find the eigenvalues of the matrix below. Now before we do this, keep in mind that eigenvectors and eigenvalues are important tools in many applications in mathematics, physical sciences, engineering, and data analysis, just to list a few. And what's interesting is that you likely found this video by using a search engine such as Google. And it turns out that the Google PageRank algorithm, the theoretical framework behind Google's search engine, is an algorithm for solving a huge eigenvalue eigenvector problem. So with that said, to find the eigenvalues and eigenvectors, we have to follow these two steps. The first step is to solve the determinant of the matrix minus lambda, which is simply a scalar, times the identity matrix. Here's what I mean. So we'll take matrix A, 4, 0, 1, negative 2, 1, and 0, negative 2, 0, and 1, and we will subtract it by the scalar lambda times the identity, which has the leading ones along the main diagonal and every other element is 0. Once we subtract these two, we can then find the determinant using cofactor expansion. So let's go ahead and do step number 1. When it comes to subtracting two matrices, you will take each of the elements and subtract them by the other matrix. So 4 minus lambda times 1 is equal to 4 minus lambda. For the next element, I'll take 0 minus lambda times 0, that's 0. 1 minus lambda times 0 is 1. Next row, negative 2 minus lambda times 0 is negative 2. 1 minus lambda times 1 is 1 minus lambda, and 0 minus 0 is 0. Negative 2 minus lambda times 0 is negative 2. 0 minus lambda times 0 is 0. And 1 minus lambda times 1 is 1 minus lambda. I'll make some more room. And at this point, we have to solve for lambda. Now, of course, we can use cofactor expansion, but since this is a 3 by 3 matrix, we can actually use the trick that we learned when it comes to the determinant of 3 by 3 matrices, which is this. You rewrite these two columns right over here. Let me show you. 4 minus lambda minus 2 minus 2, 0, 1 minus lambda, and 0. And you multiply along the diagonal. So you multiply these three elements, then you multiply 0 times 0 and negative 2, and you're summing these up. And you multiply 1 times negative 2 and 0. So add those up and then subtract by the product of the opposite diagonals. So this one, and this one. Here's what I mean. 4 minus lambda times 1 minus lambda times 1 minus lambda gives us this expression. 0 times negative 2 is 0. 1 times negative 2 times 0 is 0. And now going in the opposite direction, we subtract 0 times negative 2 times this gives us 0. This times that is also 0. I'm not going to write down 0 again. 1 times negative 2 times 1 minus lambda gives us negative 2 bracket 1 minus lambda close bracket. I'll simplify this a little bit. 4 minus lambda, the same thing here. And over here we get plus 2, 1 minus lambda is equal to 0. I'm making it equal to 0 so that I can solve for lambda. We have a common factor, this one and this one. So we have 1 minus lambda, and the rest is 4 minus lambda. That's also in its own parentheses, 1 minus lambda. And over here we have plus 2. This is a good situation because we can now solve for one of the versions of lambda. It's going to be 1 minus lambda is equal to 0. So one of our lambdas is 1. And if we combine these, we should end up with a quadratic. Let's go ahead and do that. If you combine them correctly, it will look like this. There you go. And we'll set this equal to 0 as well. And you should end up with 2 and 3. So our solutions are 1, 2, and 3. What you see right there are the eigenvalues for this matrix. If you'd like to see some more examples, make sure you watch part 2 of this series where we cover the solution for question 2 and 3.